This is Mr. Potter. What we're going to be talking about today and for the rest of this unit is we're going to be introducing the concept of recursion. So the first thing I want to talk about is what is recursion. So I need to talk about it from a mathematical standpoint because it uses functions, and then I'll talk about it from the Python idea. The idea of what we're doing in Python. So let's say that I've got this concept of factorial. In mathematics, we have the idea that I could take a number like 5 and apply a exclamation point to it, and this is called 5 factorial. And what this really means is this is really supposed to be 5 times 4 times 3 times 2 times 1. So I would end up with 2 times 3 is 6, 6 times 4 is 24, and 24 times 5 is 120. If I wanted to write some idea of how to calculate this, what I could do is I could say, well, my answer, 5 factorial, is really 5 times whatever 4 factorial is. Now, I don't know what 4 factorial is, but I could find it out because I could say 4 factorial is really 4 times whatever 3 factorial is. Now, I have no idea what 3 factorial is, but I know that that's supposed to be 3 times whatever 2 factorial is. And of course, I run into the same problem, 2 times 1 factorial. What is 1 factorial? Well, 1 factorial is 1 times 0 factorial. But here, we actually have a definition in mathematics for 0 factorial. 0 factorial is defined to be 1. So in other words, whenever I see 0 factorial, I say, hey, that's 1. And remember how you said it had to be 1 times whatever I am? So it's got to be 1 times 1, which is 1. That means this 1 factorial is 1. But now I need to multiply that times 2, and that's going to give me 2. That means that 2 factorial is 2. And then I had to multiply that times 3, so 3 factorial is going to be 6. But then I had to multiply that times 4, so 4 times 3 factorial, 4 times 6 is 24. And so I've got this 24, that's what 4 factorial is, but I'm supposed to multiply that times 5, and I get 120. And so that means that 5 factorial is equal to 120, and I do it through this process of trying to find a simpler problem. I wanted to find 5 factorial, but in order to do so, I needed to know what 4 factorial was. I wanted to know what 4 factorial was, but in order to do that, I needed to know 3 factorial, and 2 factorial, and 1 factorial. And eventually I got down to 0 factorial, something that I knew by definition. And this idea of getting to something smaller and smaller is called a base case. So ultimately, I want to reach a base case, and I want to do it through a process of iteration. The idea of iteration is that I wanted to go from 5 to something smaller, to something smaller. And indeed, I want to get closer and closer to my base case. My base case is 0. So to get from a 5 closer and closer to a 0, well, I know that 5 minus 1 is 4. And I know that 4 minus 1 is 3. And 3 minus 1 is 2. This is my iteration. So, in fact, recursion actually uses 2 ideas here. The 2 ideas that we talk about are iteration and a base case. And if I'm missing any of these, will cause an infinite loop. Now, when I talk about an infinite loop, I'm talking about a program that runs forever. So if I'm missing either of these, either this base case that I'm trying to reach, or this iteration, which is going to take steps towards a base case, if I'm missing either of these, I'm going to end up with an infinite loop. Now, in our previous lesson, we talked about how to write a definition of a function. And so what we're going to do is we're going to take a look at this function and have this function call upon itself. But we're calling upon ourselves with an iterated value. In other words, this value should be getting smaller and smaller and smaller, ultimately reaching our base case. And so we're going to go to our sculpt.org website, the website that we normally do our Python programming, and we're going to talk about how this looks. So I've got my Python program set up here. I'm going to get rid of all of this default stuff. We're just going to put our name in here, mistapotta. I'm going to import, oops, don't put a comment there, import turtle. And I'm going to say t gets turtle dot turtle. So there's my turtle constructor. And we're going to define a function here. So I'm going to define, using def, spiral. And inside here I'm going to have a parameter called length. And remember that I'm using this as defining it. I need to set up a scope, so I set up a colon, and that means that everything that I type from here on out, as long as it's indented, those 4 spaces here, as long as I have these 4 spaces of indentation, I know I'm going to be fine. It's going to be repeated. Now, in order to draw a spiral, I need to draw a line segment of a particular length. So let's say t dot forward length. And then I need to turn a certain amount. So I'm going to say t dot left 90. And then I need to draw the rest of the spiral. So I'm going to call on spiral, but I don't want to call on it with my length. I need this to iterate. I need it to get closer and closer to some base case. So I'm going to call spiral on length minus 5. So in other words, my spiral function will call upon spiral. But there's something very important. I don't have my base case. I have my iteration. And my iteration is that I'm going to be going down by 5s. But I need my base case, and my base case is going to use this keyword here, if. If length is greater than 0, that is my base case. In other words, stop if the length is 0. But notice that I've got this colon here, so that means all of these need to be advanced 4 spaces as well, because I want all of this code only to be run under the condition of this base case. In other words, only when this base case it hasn't been reached yet. So if I wanted to draw a spiral and I wanted my spiral to start off with a certain length, I would do something like spiral 100. And what that will do is that it will draw a line with 100 pixels long, because 100 is bigger than 0. And then it'll move left, and then it'll draw a line 95 pixels long, because 95 is bigger than 0. It'll turn left, and now we're going to draw something 90 pixels long, because 90 is bigger than 0. And we're going to do this repetition over and over and over again. So what happens is I end up with a shape that looks like this. There's the 90, the 85, 80, 75, 70, 65, 60, 55, 50, 45, 40, 35, 30, 25, 20, 15, 10, 5, 0. Once I hit that 0 pixels, 0 is not bigger than 0, and none of this code gets run, which means I don't recur. I don't run myself again. I only run myself again if my length is bigger than 0 and I take 5 away. Notice that each one of these pixels that were drawn were 5 pixels, and each one of these line segments that we drew were 5 pixels shorter than the previous one. If I were to change this iteration to something a little bit smaller, say going down by 3s, so well then now each one of these segments is going to be just 3 pixels shorter, and my spiral will end up being tighter. And if I made that iteration bigger, then I'm getting closer to my base case sooner, and my spiral will be much looser. I'll have a lot less space in it. So I could see that if I made my interval 8, then I've got 100, then 92, then 84, then 76, then 68, then 60, and my spiral is very loose fitting. Another thing that I could do is, let's go ahead and change this back to 5. But I could change the angle. I mean, instead of doing a 90-degree angle, I could do a 60-degree angle. And if I turn left 60 degrees each time, that's going to end up giving me this hexagonal spiral. And of course, it's a pretty loose spiral because this length of 5 means that each one of these bases, I went from 100, 95, 90, 85, 80, 75, 70. This was 100. This is 70. If I do another loop around, that's going to be 6 times 5, so this is 40 now, because I've taken 30 away. Then 30 more away makes 10, and then that's the end of my spiral. If I were to want to make this a little bit tighter, I would probably do something like 2, just to make it so that I've got much many more iterations, many more steps until I reach my base case. So the idea behind recursion is two things have to happen. Number one is that I have to have a base case, something that's going to make me stop. Because if I didn't have this, and remember that first time I ran it, I didn't have it, then I could have a program that technically runs forever. So I have to have that base case, but the other thing I have to watch out for is, do I have iteration? Do I get closer and closer to 0? Because if I do this, then it's going to keep drawing hexagons that are all the same size, and it's just going to keep tracing itself forever. If I'm missing either of those situations, either a base case or the iteration, I run the risk of having an infinite loop. This turtle will go around in hexagons forever, as long as I let it, because there's no reason for it to stop. I've created what we call in computer science an infinite loop. Now, the key thing that's to this, the key thing that allows us to do this, is this idea of an if statement. The idea that some code gets run conditionally. This code's only going to be run if this statement here is true, if length truly is bigger than 0. Which is why this goes forever, because I'm constantly having a length of 100, and 100 is never greater than 0. If I were to bump this down to, say, counting down by 3s, and I made this angle 120 instead, then we'll have a spiral of triangles that gets tighter and tighter. But notice that because the pixels are only 3 apart, I end up with this interesting effect, this interesting spiral effect. And I could break that down to a 1 pixel apart, where it would almost be like a completely filled in triangle. But that's something that you can experiment with. The key thing to remember when we're dealing with recursion is that we have to have a base case, some conditional statement that's going to stop us from going on forever. And we have to have some iteration, something that allows us to get closer and closer to a base case. So once again, this is Mr. Potter. Thank you for watching. Have a great day.